Okay, today's learning goal is division of fractions. So we're going to look at some strategies to divide fractions, both improper and mixed. So we'll look at a number line, patterning, and eventually our shortcut. And hopefully we can really drive the idea home of what this actually means. So is there a difference between the following two statements? What is 6 divided in half? And then the second statement is what is 6 divided by half? Okay, and well, the short answer is yes, there's definitely a difference. What is 6 divided in half? Well, if I have 6 circles and I divide them in half, I'm going to divide them into two equal groups. And what we would find that 6 divided in half is 3. Okay, because I have 3 in each one of the groups. So you're taking the original amount and you're breaking it up into two separate groups and then counting how many are in each group. What is 6 divided by half? The second question is asking you how many halves fit inside your 6. So if we draw the same 6 blue circles, the difference now is we're not trying to break them into two separate groups. We want to count up how many halves there are. Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer here is 12. Okay, so there's a bit of a language issue involved with doing division, especially division with fractions. This is why I wanted to point this out. The calculations aren't super difficult, but it is important to understand what the question is asking. Okay, so let's try a couple here. 3/4 divided by 1/2. So I'm stating this question right here. How many halves fit into 3/4? So I've drawn my 3/4 right here. And now I want to see how many halves fit inside of it. Well, if we look at this picture, we definitely have one full block of a half that fits inside 3/4. Now, if I take another half and I put it here, it's too big. It's beyond the 3/4. But what I can notice is a portion of that half fits. Well, and the portion of that half is actually a half. So 3/4 divided by a half, okay, it's asking you how many of these halves fit inside? Well, one full block and half of the other block. So the answer here is 1.5. Okay, so we're going to try a couple of these. They take a little while to get used to. 1.5 divided by 5/8. So this is asking how many 5/8 fit into 1.5. So I have my 1.5 along the top here. We can definitely see that one block of 5/8 fits for sure. If I drag a second block over, let's see where we are. Okay, so 2 blocks of 5/8 for sure fit inside this. And then lastly, a portion of that final third block fits. So if we count these up, we have one full block of 5/8 there. We have a second block of 5/8 there. And of this last one, we have 2 out of 5 of those pieces. So we have 2/5. So the answer here would be 2 and 2/5. Okay, and we're going to come back and verify these with other techniques just to make sure they work. But we just want to get that idea of what the question is asking. Okay, last one of this style. 2.25 divided by 11/16. Oh my goodness. So let's just agree we won't be drawing a lot of these, but they do help with our understanding. So we have 2.25 laid out on top. Here's 11/16. So I'm going to put that one so we can see there are definitely 2 blocks of 11/16. If I can get the third one, come on. Move, move. It's being finicky. Okay, so we have 3 blocks and then, come on, get in there, right there. Okay, so let's count them up. We have one full block here, one full block here, one full block here, and then of this one we only have 3 out of the 11 blocks that fit inside. So the answer to this question would be 3 and 3/11. Okay, and we're going to go through and I'll show you how that works when we get to our shortcut, but that's the idea. Okay, so now if we look at a patterning approach, if we have 10 times a half, that's 10 groups of a half, and we can draw that out if we want. Okay, so there's, and if we count them up, 1, 2, 3, 4, 5, 6, 7, oops, 8, 9, 10. So there's 10 halves all put together, and they make a total of 5. Okay. If we put our placeholder in down here and we multiply across the top like our multiplication shortcut says to do, we would have 10 over 2, and if we reduce that, that would be 5. Okay, now let's flip over to the division. 10 divided by 2. So if you had 10 purple circles and you broke them into 2 separate groups, you would have 5 in each group. So this answer is 5. Okay, so now 10 divided by 2, what I want you to start looking at, compare this one and this one. Okay, visually look at what's the same, look at what's different. Okay, they both yielded the same answer of 5, and I'll tell you in a minute, I'm just not going to do it yet. Okay, so let's look at the next one here. 6 times a half. Okay, well that's 6 groups of a half, so if we draw this, and we cut them all, and then we count them, 1, 2, 3, 4, 5, 6 halves is the same as 3 whole units. If we do this with our shortcut, multiply across the top, multiply across the bottom, and 6 divided by 2 is 3. Okay, if we come over to the division, 6 divided by 2, if I break my 6 up into 2 separate groups, then each group has to have 3 in it. So again, we get the same answer, and I would like you to take a look at this, at what's the same and what's different. Okay, so if you'll notice, the first term, 6 over 1, stayed the same. The second term, though, it has the same numbers, but they've been flipped. Okay, and that's an important observation. And the other key piece is the operation is different. So one is multiplying by a half, the other is dividing by 2. So this leads to our first sort of big connection. Dividing by 2 yields the same result as multiplying by 1/2. Okay, so dividing by 2, and I'm going to put the placeholder in there, is the same as multiplying by 1/2. Okay, so let's just explore a little bit more and then we'll see if we can bring it all together. Evaluate and compare. So 12 divided by 4. So if you have 12, 5, 6, 7, 8, 9, 10, 11, 12, and if I have to break this up into 4 equal groups, 1, 2, 3, 4 groups, we can see that there is 3 in each one of those groups. We could also look at how many groups of 4 fit inside of 12. There would be 1, there would be 2, there would be 3. So either way, 12 divided by 4 is 3. Okay, now there's a couple of things we're going to look at. I'm going to put placeholders in here just to help see everything. Notice the first term is still the same, 12 over 1 for both terms. Dividing by 4 over 1, and then we're going to compare that to multiplying by 1/4. Okay, so 12 times 1/4. I'm just going to draw a couple of big circles, and I'm going to chop them up into quarters. And now let's count how many quarters are actually here. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12. So there's 12 quarters, and if they're rearranged, they make a grand total of 3. Okay, so again, let's take a look. Dividing by 4 over 1 got the exact same result as multiplying by 1 over 4. Okay. Let's try one more version here and see if we can spot it, and then I think I'm close to giving you the shortcut. Yep, it's on the next slide, so let's take a look. 6 divided by 3/4. So this is asking me how many 3/4 fit into 6 whole units. So let's try this. So there's 1, 2, 3. That's one group of 3/4. 1, 2, 3. That's a second group of 3/4. 1, 2, 3. That's another group of 3/4. We'll go back. We'll try x's this time. Another group of 3/4. And if we count those up, a lot of people would say, hey, that's 6 groups of 3/4. And they would be close, but they wouldn't be right. What we're also missing is, let's do a highlighter, this one, and this one make another group of 3/4. This one, and this one make another group of 3/4. So if we were to count this up, there's one group here, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups, the yellow, 8 groups, the light blue. So the answer here is 8. Okay, so there are 8 groups of 3/4 inside a 6. Okay. Now, if we want to do a little experiment, let's see. Instead of dividing by 3/4, let's just test this out. What if we multiply by 4/3? Just let's take a look and see what happens. If we multiply across the top now, that would be 24. If we multiply across the bottom, that would be 3. And 24 divided by 3 is, oh my goodness, 8. I think we're on to something. All right, so here's the shortcut. When you divide by a fraction, the shortcut is to invert or flip the dividing term and multiply those two terms out. Okay, so here's what it would look like. Let's do 5/8 divided by 3/4. Okay, so that would change into the 5/8 stays the same. Okay, so we're dividing by a fraction. We're going to invert or flip the dividing term. So the dividing term, instead of 3/4, becomes 4/3. And we're going to switch to multiplication. So please note the things that changed. The sign changed, and the second term changed, not the first one. So now if we multiply across the top, we get 20. If we multiply across the bottom, we get 24, and the answer would be 20/24, but we're going to try and reduce that. So we could drop that to 10/12, and then we can drop it a little further down to 5/6, and that would be the final answer. Okay, let's just round off a bit more of this discussion and we'll test our theory. So 5/8 divided by 1/4. So the red line here represents 5/8. I want to know how many groups of 1/4 fit inside the 5/8. So let's just do this. There's one group of 1/4. There's another group of 1/4. And then I have half of the last quarter. So if I just count these, I have 1, 1 and a half. So I have 2.5 of those 1/4 fit inside of 5/8. That's using that number line model. Let's go and test our shortcut. So we would do 5/8. Instead of division, we're going to do multiply. And instead of dividing by 1/4, we multiply by 4/1. So that's the invert or flip right there. Now if we multiply across the top, I get 20/8. And now if we use our lowest terms, how many 8s fit inside of 20? Let's actually just reduce it first. So let's go down to 4s, go into both numbers. This becomes 5/4. Oh, no, pardon me. Let me do that again. 5/2 would be more correct. So let's say we're going to divide both top and bottom by 4. So this becomes 5/2 or 2.5. And oh my goodness, I get the exact same answer. So our shortcut looks like it works. Okay, so we'll do a couple extensions and some more challenging applications. What happens if we have this type of problem? 6 3/8 divided by 2 1/8. Now, if we want to make an estimate, we can just go 6 divided by 2. So we should be in the range or in the ballpark of 3. Now, if we have a problem like this, we normally find it's easiest to convert these to improper. Okay, otherwise it starts to get a bit messy. So if we want to convert these to improper, we multiply these two together and then add that piece. So the first term would be 8 times 6 is 48, plus 3 more is 51/8. Okay, I'm still going to leave it as division. And we're going to convert this term to improper, so we multiply and then add. 8 times 2 is 16, plus 1 more is 17. And now I'm in a place where I can use my shortcut. So I'm going to leave the first term. I'm going to change it to multiplication, and I'm going to multiply by the reciprocal. So take a second, make sure you map all those pieces out. First term stays the same, operation changes from division to multiplication, and you flip or take the reciprocal of the term you're dividing by. Now, I can multiply across the top here. I can do this, and I can get 408, and then I can multiply across the bottom and get 80 plus another 56, 80, what's that, 136. But that starts to be really nasty. Okay, so what I want to look at is there a faster way? And there is. So if I look at this expression here, I have two divisions and a multiplication. And in our bedmaster order of operations, it says we can do multiplication and divisions in any order we like. So if I looked at these two right here, what is 8 divided by 8? Well, 8 divided by 8 is 1, so they cancel each other out. So that leaves me with 51 over 17, which is a lot smaller number. So I have 51 over 17. Okay, and now I'm very comfortable with my multiplication facts. I could go over to the side and do some repetitive subtraction and see what happens. Okay, and what you'll find is that 3 groups of 17 fit inside 51. This answer is a 3. And if you wanted to, you could go over here and check on your calculator, punch it in, 408 divided by 136, you get a 3. Okay, so you can do very complex problems with this, and it still works nicely. Find the missing dimension. So this is an area problem. So for a rectangle, area equals length times width. Okay, so our area we've been given here is 24.5. Our width is 3.5. We want to find the missing length. So if we have this case, area equals length times width. Okay, we know the length, or sorry, the area, we know the width. If I want to find the length, this is a division case. So I can go area divided by width should give me the length. So if I take the numbers I have, length should be 24.5 divided by 3.5. Okay, now you may not like the way this is written, and this is one of the things you're allowed to do as the person solving the problem, is you can take the 24.5 and rewrite the problem this way. Okay, and you're totally allowed to do that. And again, I would probably do this question in improper. I would change this to 49 over 2. I would change this to 7 over 2, and then I would start my shortcut. Okay, so then I would have 49 over 2 times 2 over 7. And again, I could multiply across the top, multiply across the bottom. It'll generate some larger numbers. It would generate 98 over 14. And then I can try and reduce that from there. Or I can recognize a few things. This 2 on the top cancels with this 2 on the bottom for 1. And then all I have to do is 49 divided by 7. And that is answer of 7. So the width, or the length in this case, is 7 meters. Cool? Okay, the last one, I think, I hope. It's getting a little long here, sorry. 1/2 cubed. So why do you get a smaller answer than what you started with? Well, if you remember what this means, this is a half times a half times a half. Well, if you look at the first two, when you multiply a half times a half, you get 1/4. So you've already made the number smaller. If you multiply by another half, that result gets even smaller because you keep taking successive halves of whatever number you generated with the previous terms. So this turns into 1/8. So if you are multiplying by a number that's less than 1, you will progressively make smaller and smaller numbers. Okay, last one. Are these different or the same? Okay, these are actually the same. And this is one of the frustrating things in math, because there's a different way to show or express the exact same thing. It can be very confusing for people. Multiplying by a half, dividing by 2 gives the exact same result. Okay, so these are both the same thing. Okay, so you have a task for division of fractions. Thanks for tuning in. Sorry it was a bit long. Hope you got something out of it. Thank you.